Hi students, welcome to chemistry classes. In today's session, we are going to start with the next chapter. It's the first chapter, unit number 7, P block elements. Student, P block elements nothing but group number 13 to group number 18 elements are called P block elements. So, in your PUC first year, you will learn about P block elements, nothing but group 13 elements, nothing but boron family, and group 14 elements, nothing but a carbon family. Okay. And next, in this class, we are going to start with the next group elements like nitrogen family, oxygen family, and halogens and noble gas elements. So here, unit number 7, P block elements. Unit number 7, P block elements. Students, unit number 7, P block elements. This chapter carries total 10 marks for your annual examination. This chapter carries 10 marks. And here, 1 marks and 1 question from a 1 mark section. 1 question from a 1 mark section and 3 questions from a 3 mark section. 1 question from 1 mark section and 3 questions from a 3 mark section. Total here 9 and 1, total 10 marks. So this chapter carries total 10 marks and very easy chapter. In this chapter we are learn about the group number 15, group number 16, group number 17 and group number 18, nothing but noble gases. Okay. So let us start with some basic terms and some basic explanation regarding P block elements. So students, then tell me what is meant by P block elements? P block elements nothing but group 13 to group 18 elements are collectively called as a P block elements. And one more, in P block elements, most of the elements are non-metals. Most of the elements are non-metals. Although P block element contains metals, non-metals, and metalloids. And students, this P block elements, its general electronic configuration is. What is the general electronic configuration for P block elements? Noble gas NH2 NP126. This is the P block elements general electronic configuration. And what is the outermost electronic configuration? NH2 NP126. So student, you can take one example here. I am going to take one example, lithium. Yes. What is the atomic number for lithium? Lithium atomic number 3. Yes. And what is the electronic configuration? 1s2 and 2s1. 1s2 and 2s1. Here S subshell is there. Here also S subshell is there. Means this element belongs to S block. This element belongs to S block element. Okay. Next, again I am going to take one more example, that is a boron. Boron, hydrogen, helium, lithium, beryllium, boron. Atomic number is 5. And what is the electronic configuration for a boron? 1s2, 2s2 and 2p1. Means here the outermost electron or the characteristics electron enters into p subshell. Or simply you can say outermost electron enter into p subshell. That is why this elements belongs to P block. Then what is the definition for a P block element? The electron enters into p subshell. Okay, those type of elements are called a P block elements. For example, boron, carbon, nitrogen, oxygen, fluorine, neon. So these all are comes under a P block elements. So student, let us start with some important definitions and some important basic terms regarding P block element, definitions and characteristics and elements. Okay, let us start with that. Then, what is P block element? Definition for a P block element. What is P block elements? What is P block elements? What is P block element, students? Group number 13 to group number 18 are called P block elements. Group number 13 to group number 18 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 elements are called P block elements. P block elements. Student, here group number 13 to group number 18 elements are called P block elements. And also definition for one more definition for P block elements. The characteristics electrons, or you can say outermost electron enters into P subshells are called P block elements. Here students, the characteristics electron, nothing but outermost electrons, enters into P subshells are called P block elements. Example carbon. What is the atomic number for carbon? 6. 1s2, 2s2 and 2p2. Here outermost electron enters into P subshell. That is why they are called a P block element. And some of the important terms or some of the important properties of P block elements are the general electronic configuration of P block element. What is the general electronic configuration for P block element? General electronic configuration of P block element. General electronic configuration of P block element is noble gases, NS2, NP126. Noble gas NS2, NP126. This is the general electronic configuration of a P block element. And what is the outermost electronic configuration of P block element? Here, outermost electronic configuration of P block element. Outermost electronic configuration of P block element. That is also, this is NS2, NP126. NS2, NP126. So this is the outermost electronic configuration, NS2, NP126. And student, here P block elements generally, or you can say most of the P block elements are non-metals. Most of the P block elements are non-metals. Okay, most of the P block elements are non-metals, and in common, generally most of the P block elements are non-metals, although it containing metals, non-metals and metalloids. Although P block elements containing P block containing metals, non-metals and metalloids. So P block generally it containing metals, non-metals and metalloids, but the most of the P block elements are non-metal. So here metals, nothing but boron and phosphorus and aluminium, aluminium, these are the metals. And non-metal, nothing but halogens, noble gases, these are the non-metals. And here metalloids means this gallium, arsenic. So these are the metalloids. Okay. So and next one, P block elements are containing metals, nanometals, and the metalloids. And one more point, P block elements, they have a high ionization energy. Okay, P block elements are high ionization energy due to the smaller in size. P block elements, they have high ionization energy. P block elements have high ionization energy as compared to S block elements. P block elements, they have a high ionization energy. Why? Because they are smaller in size. Because they are smaller in size. P block elements are smaller in size as compared to S block elements. As compared to S block elements. And student, here ionization energy is inversely proportional to atomic size. Ionization energy is inversely proportional to atomic size. That is why P block elements, they have a high ionization energy. And next one, students, let us start with the elements. Okay, boron family, carbon family, nitrogen family, oxygen family, halogens family, and the noble gas family, and their general electronic configuration and their oxidation state and valence electrons. Okay, let's start with that. Okay, students, P block elements. Let us start with the groups. First one, in P block elements, first group is boron family. Boron, carbon, nitrogen, oxygen, fluorine, and neon. Boron, carbon, nitrogen, oxygen, fluorine, and neon. So these are the first member of P block elements. Boron is the first member of boron family. Carbon is the first member of that family, nothing but carbon family. Nitrogen is the first member of that family. That is why we can say nitrogen family or nicogens. Okay, and this is one. Oxygen is the first member of that family. That is why it is called a oxygen family. And next one, halogens, nothing but fluorine family. Okay, because here fluorine is the first member of that family, and it is also called neon family, or you can say noble gases. Okay, so first one, Bo alga intal car CJ tinle nip R and TB Osase tepo floclobro I ust and helium neon argon kryptons and on and on. So this is about the P block element. Let us start with first one, boron family. Boron family. The family members are first one boron, aluminium, and gallium, indium, and last one is thallium. Bo alga intal. Boron, aluminium, gallium, indium, thallium. Next one, carbon family. Carbon family. Car CJ tinle. Carbon, silicon, germanium, tin, and lead. Car CJ tinle. Carbon, silicon, germanium, tin, and lead. Next one, nitrogen family. So this nitrogen family, it is also called nicogens, and the compounds are called niconides because they are suffocating. Nicogens means, according to Greek word, nicogen means suffocating. Okay. Nip R and Tb, nitrogen, phosphorus, arsenic, antimony, and last one is bismuth. Nitrogen, phosphorus, arsenic, antimony, and bismuth. And next one, oxygen family. Oxygen family elements are oxygen, sulfur, selenium, tellurium, and polonium. Oxygen, sulfur, selenium, tellurium, and polonium. And next one, fluorine family, or you can say halogens. halogens. It containing most electronegative elements in the periodic table. Fluorine is the most electronegative element or more powerful electronegative element in the periodic table. Fluorine, fluorochloroiast, fluorine, chlorine, bromine, iodine, and last one astatine. Fluorochloroiast, fluorine, chlorine, bromine, iodine, astatine. And last one, noble gases, or you can say inert gases. Noble gases are inert gases because they do not react with any other elements. That is why they are called noble gases or inert gases. And due to their stable electronic configuration, they do not react with any other elements. Helium, the first member of this noble gas, neon, argon, krypton, xenon, and last one is radon. So these are the p block elements. First one, boron family, carbon family, nitrogen family, oxygen family, halogens family, and last one, noble gases family. Here, student, then what is the general electronic configuration of boron family? Let us start with boron. What is the general electronic configuration of boron family? What is the general electronic configuration of carbon family, and so on? Let us start with first one. The general electronic configuration of boron family, that is Ns2 Np1. This is the general outermost electronic configuration of a boron family, Ns2 Np1. And next one, just imagine, what about carbon family general outermost electronic configuration? Ns2 Np2. And what about this nitrogen family outermost electronic configuration? Ns2 Np3. And what about this oxygen family? Ns2 Np4. And what about halogens? Ns2 Np5. And what about the last one? Neon general electronic configuration here, Ns2 Np6. Ns2 Np6. Okay, student. So here, these boron, carbon, nitrogen, oxygen, fluorine, neon, these all are second period elements. These all are second period elements. That is why here, these all are second period elements. Then, what is the electronic configuration here? Ns2 Np1. This is general electronic configuration, and the real electronic configuration is 1s2, 2s2, 2p1. Here, general outermost electronic configuration is Ns2 Np2, and common electronic configuration or outermost common electronic configuration is 1s2, 2s2, 2p2. Here I am going to write only outermost electronic configuration here. Okay, nitrogen 2s2, 2p3. Yes, here n nothing but principal quantum number. Here n, okay, these all n are principal quantum number, means they shows energy levels. So here, boron, carbon, nitrogen, oxygen, fluorine, neon, these all are second period elements. That is why the outermost shell containing the energy level 2. Okay, 2s2, 2p2, 2s2, 2p3. Here outermost electronic configuration is 2s2, 2p4. Here 2s2, 2p5. Here 2s2, 2p6. General outermost electronic configuration of second period elements. And next one, third period element. Third period elements are aluminium, silicon, phosphorus, sulfur, chlorine, argon. Okay, then write their general outermost electronic configuration: Ns2 Ns2 Np1. Then here n nothing but here principal quantum number, that is third period element, here nothing but 3. Okay, 3s2 3p1. General outermost electronic configuration of aluminium is 3s2 3p1. Here n nothing but 3. Here n nothing but 2. Here n is 3. Okay, because energy levels and quantum numbers. 3s2 3p1. Here 3s2 3p2. 3s2 3p3. 3s2 3p4. 3s2 3p5. 3s2 3p6. Okay, next Same. N equal to here 4 means these are a third thread element, and these are a okay, second, third, these are fourth thread element, these are a fifth thread elements, and these are a sixth thread elements. Okay, student. And here, what is general electronic configuration for gallium? 4s2 4p1. Here 5s2 5p1, 6s2 6p1. Okay, like that you can follow the all the elements. And student, one more. These p block elements containing metals, non-metals, and the metalloids. Here, gallium and silicon, and germanium and arsenic, and this one, antimony and tellurium. These are metalloids. These are metalloids. And here, remaining are boron, aluminium, indium, gallium, tin, lead, and bismuth. These are metals, and remaining these all are non-metals. Okay, students. Here, gallium, silicon, germanium, arsenic, antimony, and tellurium. These all are, means these 6 elements are metalloids. These are metals, and remaining these are non-metals. So this is about the p block elements, general properties and general characteristics. Okay, this one.